Hello friends, welcome to the Go tutorials. Today we are going to see a new section called slices. In previous tutorials we have seen arrays, of course, which is a collection of data we have discussed in the previous presentation. Now we are going to see a new concept called slices. What are slices? Yes, slices are nothing but a layer over the arrays. In arrays, we have some set of values which are static, defined with a size specifier. We cannot do any changes to the dimension and all, right? Yes. So, take an array, we will apply a layer which is an abstraction over the arrays. That particular layer is responsible to take care of dynamic operations on the arrays. So slices are nothing but dynamic arrays. We can put it in this way. We can do dynamic operations like resizing an array, adding a values, removing a value from an array. It is just like an abstraction over the existing static arrays. So to perform dynamic operations over the static arrays, a new data structure is created in Go programming language, which is called as slice. This is what we are going to see today, right? So I am going to open my command prompt. I am going to the Go demo folder. Let me maximize the screen. Yes, I'm going to create a simple example for you to demonstrate what's a slice is. Slicedemo.go package main import format function main. Right. So usually how do we declare an array? Variable, array variable name and open 3 int. So this is a typical array declaration, right? What the statement says? The statement says I am declaring an integer array variable a of size 3. What usually we do? This is how we declare an array. Whereas in slices, it is a very simple difference between arrays where we need to ignore the size in the dimensions. So if you specify a size value in the square brackets, it will be an array. If you ignore the size here, it will be a slice. So what does the statement says is declare an integer variable, declare a variable a which is an integer slice. That is what the statement says. Now, what I will do, I will try to print the statement. Format.printf, the size of, let us see the length. The length of a is percentage %d. So what I am trying to say here is length of a. Go run slice demo. See here the length of a is 0. So we have initialized, we have declared a slice without any value specified here. So it is defined as a slice. So it is not having any value, so it prints the size as 0. Right. This is one way of declaring a slice. We have another way to declare a slice. How we will do? Using colon equal to declare and assign operator. We have already seen this. Right. Now I am going to use a statement called make. This statement is very much useful to create arrays, any type of objects, slices, whatever we wish, we can instantiate and create them. Right. Now what I am doing here is make, opening the same bracket. What I am going to do, I am going to create an integer slice, int, comma, here I can mention the size. This is another way to create a slice. So what I am asking here is I am going to instantiate. Here there in the first statement we are just declaring a variable a as a slice, whereas in the second statement we are declaring as well as instantiating. So declaration as well as instantiation of a new slice b of type integer. This is the meaning of the second statement. So now what I am going to print here is the length of b is percentage %d. Now length of b I am including to the existing print statement. So the print statement needs to print the length of a and b. See here, the length of a is 0, the length of b is 5. So why it is 5? I have mentioned during the make, I first mentioned the data type in which the slice belongs to. So a make, I am going to make. What I am going to make? I am going to make an integer slice. I am going to make an integer slice of size 5. The length of the slice is being defined here, whereas in the first statement it is not being defined, so it's printed as 0. Right. Now I am going to create a one more slice, which is the variable c. Okay, make of open close integer 0. Okay, in the previous statement I have declared it as 5. Here I have declared it as 0. So now I am going to print the length here. Length of c is percentage %d. So let us try to print the same length of c here. So three different slices we have created. So this is an empty slice declaration. This is of course a slice initialization and instantiation using, not initialization, it is an instantiation using the make statement with the size specified here. Here also I am doing the same thing but with the size as 0. Now we are done with the code. I am compiling and see here. The length of A is 0, length of B is 5, of course we know that, but the length of C is also 0. So the first and the last statement looks alike here. That means this variable A declaration and variable C that is instantiation looks same, but there is a difference. This is a simple declaration whereas this one is an instantiation. What is the difference between them? Internally, a slice is organized of three components. The first component is a pointer, the second component is a length, and the third component is called as a capacity. So every slice has these three components. So we are aware of the length because whenever we deal with the size of the slice, we can get the length. We know that property. But there is one more thing called a pointer. Every slice is having some pointer which is pointing to a value. So whenever you instantiate a particular slice, it creates a pointer and the pointer will be pointing to a particular address. So here in this statement, even though the size is 0, we are using make statement to instantiate a particular slice. So here a pointer will be pointing to a new address. So from that address, whenever you are pushing a value or you are pulling out, the pointer will keep on navigating throughout that particular slice. So the pointer will be pointing to a new address inside the slice for the slice. So this is the statement because some instantiation is happening. So here it is slice instantiation. So pointer will be pointing here, but here it is just a declaration. So the pointer will be nil. What does it mean? It doesn't has anything. It don't have any data. So the pointer is an empty. In other languages we can tell it is a null. So in Go language we are telling this nil. So this is called nil slice. This slice created using the make statement, even though the size is 0, the pointer will be pointing to the new address. But the value inside the address is empty. So this type of slice is called empty slice. Even though for a look, both of them, it's a simple slice declaration and a make statement with a size 0 looks one and the same, but internally a pointer will be created for the slice created with make and it is empty with the values. So it is termed as an empty slice, whereas while doing declaration there will be no pointers at all and the pointer will be nil. So this type of slices are called nil slices. So these are all the main two types of slices. Okay, so already we have seen pointer, what is a pointer and what is the length. And one more thing which is called as capacity, which is very much interesting and a new term. Let us see about capacity much more in the next code and all next program which we are going to see. Right. So here we declared a variable a without specifying any size. So if you are not mentioning any size, it is a slice. If you mention a size in between, then it will be called as a array. So the difference between array declaration and a slice declaration is just the size within the square brackets. Right. Now, what are all the things so far we have seen? We know how to create a slice with its length specified. Right. Now we are going to initialize a slice. How to initialize a slice? Let us do this. I'm going to have d colon equal to. So I'm going to declare and assign. I'm going to initialize. Declare and initialize. So what I'm going to initialize? I am going to initialize an integer slice. What are all the values? Interestingly, they are 10, 20, 30, 40 and 50. These are all the 5 values I am initializing for the slice named D. Now, I am trying to print length of D is percentage %D. So, I am including the slice D also here. So what is happening? In A, we have not mentioned any size, so it is 0. In B, we mentioned the size as 5. In C, we are mentioning the size as 0. Whereas in D, we have not mentioned the size, we just initialize the values. But how many values we have been initializing it? 5 values. So based on the number of values initialized, the Go compiler will identify the size of the slice dynamically. So let us see what is the size. The length of D is 5. See here, even though we are not mentioning size, but just we are initializing some values for that particular slice, the Go compiler will understand the size of the slice based on the number of values initialized. So this is a dynamically it will identify. So Go compiler dynamically identifies the size, the length of the slice D based on the number of values we initialize. So we are initializing 5 values here. So the length or the size of slice D is 5. So this is what printed here as the length of D is 5. Okay, right. So we know declaring slice with slice literal, which is nothing but initialization, creating a slice with its length specified. We have seen nil slice and empty slices. Now we are going to see something important, which is creating a slice from other slices. Let us see this in some more detailed manner. Slice test, I can name it as slice test. Same package main, import format, function main. So here I am going to mention the same style of size, a equal to the same good old integer slice with some set of values, this time as 400, 500. It is as simple as this. So we know it is a very simple slice. We have declared and created it. Now what I am going to do is I am going to create a new slice. This new slice will be created from an existing slice. See, for example, already we have created a slice called A with some set of values. Now I am going to create a new slice B with the same values of A. That is, I am going to slice out the values from A. B is not going to be a new slice. B is going to be operating from the values of A. So I am going to slice up some set of values from A and create B out of it. So let us do the same thing now. What I am going to do, I am going to declare a more slice B colon equal to, from where I am going to create a B, I am going to create B from A. So what are all the values from A you need for B? Because A is a slice which has the indices 0, 1, 2, 3, 4. we have 5 values. What does the index 0 contains? 0 contains 100, index 1 contains 200, index 2 contains 300, this has 400, and this has 500. So this is the value distribution in the slice 0 to 4 for the A slice. Because slice are nothing but arrays, their indices starts with 0. Perfect. Now what I am going to do, I am going to slice out this set of values from A to B. I am going to ignore the 0th index. I am going to consider from the first index to second, third and fourth. So my values for the new slice will be these 4. Right. So what I need to do for that? A is the slice. I need to put 1 colon 3. What is that 3? What is that 1? First I will let you know what is this 1. 1 is nothing but the index from which the slice needs to be created. So from the slice A, the index 1 from which the slice will be created. So the index 1 is nothing but this 200. From this 200 up to 500, the slice will be stripped out. Now what I am going to do, I am going to print the length of A is percentage D. So we all know about this, and I am going to print the length of A as well. So from our code, from our set of values, we know the length of A is 5 because A has 5 values 100 to 500. Let us forget about B for now. We are not going to print B anymore. I will comment this out. Let us see the values of A now. I am going to compile now the code. Go run. If you see, so 1 second, it's not println, it is printf. Sorry. Yeah. See here, the length of A is 5 because we have 5 values. Right. Now, what we are going to do is, already we have printed the length. Now, I am going to print the capacity. Capacity of A is percentage D, comma capacity of A. Here if you compile and run, you will get the same output. The length of A is 5, the capacity of A is also 5, because whatever the being the length of a particular slice, that will be considered as a capacity. So here the length of A is 5, so the capacity of A is also 5. There are scenarios where a length and capacity may differ. For example, I am going to declare a new particular slice here, new, that is called x, which is an integer slice with the size 5. We know this. So here if I try to print length of B is percentage D, the capacity of B is percentage D. Sorry, not B, it is X. Let us discuss about B a bit later. Yeah. So length of X, comma capacity of X. So here we are not mentioning the size. So based on the number of initialized values, the size being inferred as 5. Here we declared a particular slice X with the size already defined as 5. Now we are printing the length and capacity of both the slices. So both are 5. Here also the length of X is 5 and the capacity of X is 5. Now what I am trying to do here is I am going to mention a capacity here as 7. So the make statement carries 3 arguments. The first argument is nothing but the slice type. Here it is integer type slice. The length is 5 and the capacity is 7. Now if I compile and run the code, you can see the length of X is 5, the capacity of X is 7. In the previous statement, both are one and the same, which is 5, because we are not explicitly mentioning any of the capacity values. If we are not explicitly mentioning a capacity value, the default length value will be taken to capacity. If you wish a capacity, you can specify like this as a separate entity. Right. So now the length is 5, capacity is 7. What is the capacity? Capacity is the maximum value it can hold. What is the length? The number of values which are currently available. So both are different, right? Now I'm doing a slight change to the values. I'm going to make the length as 7 and capacity as 5. Now I'm going to compile the code and you can see here length is larger than capacity in make, which is illegal. So always the capacity should be bigger whereas the length should be smaller. So capacity for a slice should always be smaller or equal to the slice length. This is very much important. So if it is equal, there is no need to mention a capacity, or even if you type 5 comma 5 it will take it up, but at any cost length should not be bigger than the capacity, right? So that is a small snapshot about capacity and how to create. Let us come back to our same example, right? Now I am creating a new slice called B from A. Already I have a slice named A which is having 5 values from 0 to 4 indices. Now while constructing my new slice B, what I am telling is this B should come from the first index of A. A is the slice which is already there. From first index of A, B should be created. What does it means? From A, this is the first index up to the length of A. So here what is the length of A? 1, 2, 3 and 4. So these 4 values, that is these 4 is the capacity for B, because I am constructing B from A. So here what I am trying to say the Go compiler is create a new slice B from an existing slice A from the index 1. This is what I am trying to say. Already the array starts with 0, but we are skipping the index 0 and we are starting from 1. From index 1 up to the length of the slice. Now again I am going to print the stuff here. Length of B is percentage %d, comma, the capacity of B is percentage %d slash n. Len of B, capacity of B, right? So now we are going to print the stuff for B here. See here, the length of B is 2, whereas the capacity of B is 4. Let us look each item one by one. Now let us see the capacity. The capacity of B is 4 here. Why it is 4? Because we are starting from first index. Because this is the 0th index, we are starting from first index. Totally the slice A contains 5 elements, but we are starting from the first index, so the 0th index is ignored. So 4 elements are there in A. So the size of 4 elements, the size of A from 1 to 4 is being considered for the new slice B. So the capacity is 4. Right. Now what I am going to do, instead of 1, I am going to make it 0. Let us see what is happening here. See here, the capacity is 5. So the entire set of array is being considered as capacity because we start from the 0th index. We start from 0th index. So the entire size of the array is being considered here. So this is what called as capacity. Right. Now let us come to the length here. So what we are mentioning is 3. So from the 0th index to the 3rd index, 0, 1, 2, these 3 indexes should be considered. These 3 indices should be considered. So 0 colon 3. So it starts from 1 up to the length of the slice is the capacity of the new slice of B. The length is colon 3. So this 3. Yeah. So considering the statement as 1 colon 3, I am just mentioning this. Yeah. So the length is colon 3, this part. So third index, which means the third index until the third index of slice A should be the length of slice B. So this is very much important. Let us wait. Right. So what we are trying to say here is from the slice A, go to the first index up to the third index, strip out a slice and create a new slice B. So let us compile this code and see here. The capacity is 4, but the length of B is 2. Why? Because from first index to third index we are stripping out. So from first to third there are two elements, 1 and 2. So these three values collectively called as these two variable collectively creates a new slice from an existing slice. I am just giving one more change here. Instead of 1 colon 3, let us do it as 0 colon 3. Now what will happen? A new slice will be created from A, stripping out from the 0th index to the last, which is the capacity, and from 0th index to the third index, which is for length. So the capacity will be 5, because zeroth index, from zeroth index to the last index the capacity will be calculated, whereas for the length from the zeroth index to the third index, which is 0 1 2, these things collectively is called as length. This is how this needs to be calculated. Now I am going to do a small change to the slicing part. Instead of 0 colon 3, I am going to mention it as 3 colon 3. I am mentioning it as, instead of 3 colon 3, let us make it as 3 colon 5. I will make it as 3 colon 5. Now let us run the code. See here, the length of B is 2 and the capacity of B is 2. Why the capacity is 2 here? I need to start stripping the slice from third index. So the total size of the slice A is 5. I am stripping out the slice from third index. So 3, 4, 5, 3 indices. There are two values are there. So 3 to 5, two values. So the capacity will be 2. That's why it is being printed as the capacity of B is 2. Right. Now the length is also 2. How come the length is 2? I need to take the values from 3 to 5. So 3 to 5 there are only two values. So the length is being printed as 2. Now for a change, instead of 3 colon 5, I am doing 3 colon 4. So what will happen? Just there is no change in the capacity, whereas there is a change in the length. Because instead of taking from 3 to 5, I am just slicing from 3 to 4. But the capacity is starts from the index 3 up to the whole size of the array or the slice. So that's why, that is how the capacity and length is being interconnected with each other. This is very much important to know about declaring or assigning values or creating a slice from an existing slice. This is what we call it as creating slice from an existing slice. Let us make it as 1 colon 3 so that the comment speaks exactly as per the illustration. So if you compile and run, capacity of B is 4, whereas the length of B is 2. So this is how we used to create length and capacity. Right. Now we are going to do some small changes to the values. Consider we already created a slice with the name A, right? Now what I am going to do, I am going to print it for I equal to 0, okay, I less than length of A, I plus plus. I am going to print format dot println A of I. It is a very simple statement, everyone knows this, right? Okay, so I am going to run the code. No doubt about this. It prints the values 100 to 500. Right. Now, 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 what I am going to do here, b of 0 equal to 1000. I am assigning b of 0 equal to 1000. Now, I am going to run the code. See what is happening. See what is happening. This is very much important to be noted when dealing with slices. So earlier I just printed the set of values from the slice A which printed 100 to 500. Now what I did, I just changed the values in the slice B of index 0. So I just changed the value B index 0 to 1000. But what is the output here? See, 100, 1000, 300, 400 and 500. What happened? Here there is a value 200 being printed. Now the 200 got overwritten as 1000. What is happening? That needs to be noted down here. So b of 0 equal to 1000. So here b of 0 is pointing to where it is pointing. What we are telling, B is the slice which will be initialized with the indexes from A of 1. So what is A of 1? This is the position. So this is the set of values, these are the set of values sliced from the slice A for B. So what does it means? These two values will be part of B. That means this is the 0th index of B. This is the first index of B. If we assign, this will be the second and third and so on for B. For A, this might be the first index, no worries. But we are slicing out some set of values from the slice A and assigning them to B. Here in B, we have mentioned A is having a slice, A is being sliced from the index 1 and assigned to B. That means the subset of A will be the main set of B. So even though a index is 1 for A, but it will be the 0th index for B. So B of 0 is pointing to A of 1. So if you do any change to B of 0, the value in A of 1 will be changed. So changes to B of 0 or any index of B will have a corresponding change gets reflected in A. So this needs to be noted whenever you're dealing with slices. So if you change the index 0 as 1000, then the place where the 0th index is pointing is the value 200 is overwritten as 1000. Instead of this, what I'm going to do, I'm going to change the b of 0 as b of 1. What will happen now? Instead of 300, it will be written as 1000. See here, right? So the 200 came back here, but the 300, instead of 300, it is written as 1000. So that's how the changes to the slices is happening. So the changes are not exactly happening in the slice. The changes is going and happening exactly in the slice A through the pointers pointing from the B slice. So this is very much important when we are dealing with the slices. This needs to be known. So this is the first part of tutorials, Go tutorials using slices. We will cover one more video in the next session for slices again, because slices is a new concept and have various features and varieties of handles. So we need to see one more video with the features of slices. Thanks for now. If you have any doubts or any confusions, or even if you have any suggestions, please provide them in the comment section given below. Please click the subscribe button. Don't forget to click the bell button. Based on that, you will get updates on the videos whenever it gets uploaded. Thank you for watching. We will catch up in the next session.